All right, Saunders Algebra 2. We are back. We are back with your notes video for Friday the 15th here, folks. We are brought to you by Fisher-Price, Little Tykes, basketball hoop. Want to feel like an all-star? Little Tykes, basketball. In-house studio audience being handled well by Stuart the Minion. Getting ready for their cameo in Toy Story 5. All right, little taste of linear programming. I took a course my last semester at SIU Carbondale called Linear Programming. Fantastic course. A lot of engineers were in there as well. Very useful course for people going into the workforce, wanting to maximize profit, minimize cost. Optimization was a big deal. We talked about that in calculus as well a little bit. So at a low level, this was involved. So graph the system of inequalities and name the coordinates of the vertices of the feasible region, and then find the max and the minimum values of the given function for this region. Now, we will finish that. First off, you need to add in a fourth one, or else we don't have a bound. We don't have a region. It goes on forever. An enclosed region. How about that? So you need to add that the last constraint is x is less than or equal to 5. So the first one is y less than or equal to 2x. Second one is y must be greater than x minus 6. Last one is y has got to be less than or equal to 6. And x has got to be less than or equal to 5. All right. Okay. X and y could be products, hours used, amount of hours someone has available. It could be anything. Okay, so first off, y less than or equal to 2x is in black. It's this one. Slope or y-intercept of 0, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Less than or equal to means I shade very lightly below. Next one in blue is y greater than or equal to 6 minus x. 6 is the y-intercept. I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Okay? Greater than or equal to, I'm going to shade above. You okay, buddy? You're breathing heavy there. Did you exercise a lot today? That walk really take it out of you? Y is less than or equal to 6. Horizontal line, you're going to shade below. And lastly, x must be greater than or equal to 5. X has got to be less than or equal to 5. Straight vertical line, and you're going to shade to the left. Anyway, where all the shading comes together is this region here. This is the region of feasible solutions. Anything in this region would satisfy, any points in those regions would satisfy all 4 of those constraints. Now, how I would maximize or minimize something, it's all about those vertices. What did I made a mistake? Yeah. So first off, y less than, yeah, this is actually not one of them. That is not it, because you have to shade where you're shading below this area. So I'm sorry, this right here, this is the answer, not this. Don't use pen, bad. Okay, so now I'm good. Anyway, you've got your first one. Where's this? This is at 3, 6. This is 5, 6. This is 5, 1, and that's 2, 4. Those are your 4 vertices of that 4-sided region. So write that down, and we're going to do something with that when I see you. Again, that's a very good example. I might try one more of those because that was a very good class. All right, try this one. X is between -3 and 4. Y is between -5 and 2. There, -3, 4. X is between it. -5, 2. Y is between it. And you're going to shade in between. That one's pretty easy. That was literally a 7 by 7 square. Okay, so you got some linear inequalities there. Again, make sure all of page 8 is done. Now, number 2, there's a little bit of an issue on 2. I did make a mistake. You're going to round to the nearest tenth there. Starts off pretty easy. You got to plug x plus 1 in for y, right? But you're going to find out. Uh-oh, 11x is equal to 15. X is 1.4. What? That just is what it is on there. I made a boo-boo. All right. I made a boo-boo on that one that I've never fixed. So we can handle it. Okay. Now, folks, what I want to do, first off, let's go to page 17. And actually, let's do all of page 17. Number 1, let's solve that first. Or let's graph that first equation. -2 for the y-intercepts. You can go down 3 and over 1, which I did a few times. Then I also went up 3, 1 to the left, up 3, 1 to the left, up 3, 1 to the left. 3 is your y-intercepts. But if you go down 1 over 2, down 1 over 2, down 1 over, you're getting further away from this line. You want to see where they intersect. So instead of going down 1, 2 to the right, you're going to go up 1, 2 to the left, and ding, 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 they intersect at -2, 4. All right. Take a look at number 1 here. Y is equal to 2/5 x minus 5. 5 is your y-intercept, up 2 over 5, up 2 over 5, down 2, 5 to the left, and in blue, your y-intercept is 7, down 2 over 1, 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 ding, 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 you intersect at 5, -3. All right. And pause this whenever you need. I made a mistake here. They are not going to intersect. So do plot the first one. Y is less than -3x minus 1. I've changed it for next year finally. -1 right here, going to go, sorry, -1's right here. Down 3 over 1, down 3 over 1. Okay, and then dot, 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 you're going to shade below. But here, you have 2. You go down 5 over 2, down 5 over 2. If you go up 5 to the right, they actually don't intersect until -6, 17. So that is a boo-boo. Just write, sorry, won't intersect on the 10 by 10. So let's move on from that one. Here, this first equation, y-intercepts -5. Up 1 over 1, up 1 over 1, up 1 over 1. Solid line, you're going to shade above. Y is less than -2x plus 9. There's 9. Down 2 over 1, down 2 over 1, down 2 over 1. You're going to shade below. Where is the overlap? Right here. All right. That is your answer. That is page 17. Now, I think that we can handle, first off, we can handle page 13, number 4. This one is so very easy. I give you one of the answers. Z is 2, so plug 2 in for Z in the second equation. Then you get Y is -4. If Z is 2 and Y is -4, then I can use the first equation and plug 2 in for Z and a -4 in for Y, like I did. X plus 2y plus 3z equals 6. Do a little simplifying. The 6's cancel, and x is 8. You're going to write this as an ordered triple. We'll talk about what 3 dimensions mean, how that looks, how you would graph something like that. All right, but I do want to talk about, let's take a look at 13. Yes, we're going to solve a 3 by 3. So I told you that this is new, and this will make solving the 2 by 2s so easy. If you can solve a 3 by 3, you can definitely solve a 2 by 2. You want to eliminate one of these variables from 2 different equations so that you can get something to be a 2 by 2 with the same 2 equations with the same 2 variables. Then you can solve that using elimination pretty easily. So look at these three equations, and what variable is just begging to be eliminated? Hopefully we can all see that that is z. Yes, you have a negative y and a positive y. Those can be eliminated pretty easily, but you're going to have to multiply, maybe this by 3. Here we don't have to multiply any equation by anything if I say by z. So what I'm going to do is I'm going to put equation 1 and equation 2 together because I have opposite z's. I'm going to add equation 1 and equation 2 together. That's what I'm showing here. Equation 1, equation 2, I'm going to add them together because then the z's cancel. Now I have a new equation, 3x plus 2y equals 15, and that new equation is called equation 4. That's a new one. Really organize yourself here, and we've got a good chance. Now, what am I going to do? I'm also going to I have to use equation 3 because I just used 1 and 2, so I have to use 3, and I'm going to pair equation 3 with equation 1 because the z's are opposite again. If I add equation 1 and equation 3, I get 6x. Oh my goodness. The y's cancel too. The y's and the z's cancel. 6x equals 18. You could call this equation 5, but you simply get x equals 3. So if x equals 3, I'm going to take that and plug it in for x right here. 3 times 3 plus 2y is equal to 15. 9 plus 2y is 15. 2y is 6, y is 3. I have y, I have x. I'm going to figure out what z is. I'm going to use equation 1, and I'm going to plug 3 in for x, 3 in for y. 6 minus 3 plus z is 4. 3 plus z is 4. Z is 1. And I have solved for x, y, and z. And that's a pretty easy one. 3, 3, 1 is my answer. But we'll continue to practice these. We'll practice a bunch when I see you. Again, these are definitely the hardest ones in this game plan. Let's take a look at, so we'll do page 14 together. You got some more examples. The first one of 14 is not the best, so definitely help you with that. But let's take a look at page 16. All right. On page 16. Number 7. What variable is begging to be eliminated? It's z again, so that's why I say by z. I'm going to take equation 1 and 2 and put them together because the z's are opposites. If I add equation 1 and equation 2 together, my z's cancel. I'm left with 7x plus 2y equals 2. That's equation 4. I need another equation with just x's and y's. So I want to say by to z one more time. I got to use equation 3 because I just used 1 and 2. I didn't use 3, so I need to pair 3 with something. I'm going to pair 3 with 1. Yes, you can put 2 and 3 together and subtract them. That's fine, but I always want to add if I can. So I'm going to put equation 1 and equation 3 together, and if I add those two equations together, the z's will cancel, just like they did when I put 1 and 2 together. So I take equation 1 and I add it to equation 2. I get 4x plus 3y is equal to 3. That's equation 5. Now what I'm going to do is I'm going to put 4 and 5 together. 4 and 5 together. And I'm going to ask myself, okay, now this looks like one of the first pages. What we did in class together on Tuesday. What do I want to get rid of? I'm going to get rid of the y's because I can just take this top equation, multiply it by 3. This bottom equation, multiply it by 2. Again, I'm multiplying by positive numbers, not negative here. If I multiply top equation by 3, I get that. If I double the bottom equation, I get that. The y's will cancel through subtraction. 21x equals 0. X must be 0. So if x is 0, I'm going to go and I'm going to use equation 5. I could use 5 or 4. I'm going to plug 0 in for x. I get 3y equals 3. Y is 1. I got x is 0. I got y is 1. This is a domino effect. I'm going to use equation. I go back to one of the originals. I chose to use equation 2. For whatever reason, you can use equation 3 too. It's just as easy. I used equation 2. 2 times x minus 2 times y plus z is 1. Z is 3. I get an answer of 0, 1, and 3. All right, so what I want you to do is I want you to have that same, let's do the same thing here with number 8. Now, number 8 doesn't match up perfectly. I know the y's are pretty close. I think the best thing to eliminate in 8 would be the x's, because if I multiply that by 2 and that by 2, then I have 2x, negative 2x, and I have 2x. Here, if I want to eliminate the y's, yeah, the 3 match up, then I'd have to, multiply that by 2, multiply that by 3 to get those to match up. The z's aren't great. So what I did is I multiplied equation 1 and 3 by 2. So these are my new equations. Right here. Equation 2 has not been messed with. Now, you can show your work like this. If I'm going to add 1 and 3 together first, because the x's are opposite, that's what I put. I put 1 plus 3. That's what's going to happen. I'm going to be adding equation 1 and 3 together. So the x's cancel. 4y plus a negative 6y is a negative 2y. 2z plus 6z is 8z. 2 plus 2 is 4. That's equation 4. Then I'm going to put equation 2 and 3 together. I have to use equation 3. Or I'm sorry, I have to use equation 2. I want to put it with 3 because x's are opposites again. I'm going to add equation 2 and 3 together. This plus this, negative 3y. 2z plus 6z is another 8z. That's good. And 0 plus 2 is 2. I want to put equation 4 and 5 together because the z's match up perfectly. 8 and 8 cancel through subtraction. Negative 2y minus 3y is a positive y. Y is equal to 2. I'm going to take that 2 and just plug it in wherever you want. I used equation 4. Negative 2 times y plus 8z is equal to 4. Negative 4 plus 8z is equal to 4. Z is 1. I'm going to use equation 1. X plus 2y plus z is equal to 1. X plus 5 is equal to 1, and x is a negative 4. Again, we'll practice plenty of these when I get back, and see you again. And in your video for Monday, I'm going to go over some test review questions and then finish those ACT and SAT questions with you. But this is a good video for Friday. You've got a lot of this game plan done right now. All right, that is it. This is Yak Math Videos signing out.